All right, and we're being recorded here. We have example B from section 10.4, and you, yes, you studied so little for this test that you are going to roll a die to guess for fun. You're taking a test for fun. Okay. So, each question has 5 choices, A through E, and if you roll a 1, you're going to guess A. If you roll a 2, you're going to guess B. If you roll a 3, you're going to guess C. If you roll 6, you're going to leave it blank. Not stupid, because look at the scoring system. Each question is scored 1 point for a right answer, negative 1/4 point for a wrong answer, and no points for a question left blank. So is leaving it blank better than getting it wrong? Yes. Okay, so they want the expected value of each question, and to do that, here's expected value. The formula is to take the sum of each x times p of x. And I'm going to explain what both of those little parts mean. Do we know what sum means? Yeah. Yes. Okay. Sum means to add. And we're going to add 3 things here. We're going to find the sum of something times something plus something times something plus something times something else. We need to find the sum of the 3 possibilities of answering a question. I said 3, not 6, because there are really 3 outcomes here. You could get it right, you could get it wrong, or you could leave it blank. Okay? So let's write those things down. You could get it right, plus you could get it wrong, plus you could leave it blank. So those are the 3 different things that could happen. What the x and the p of x mean, right here, the x and the p of x, x represents the value of each outcome. Like, getting it right is worth what? 1 point. So the x for getting it right is positive 1. Times, we need the probability of getting it right. When you roll the die, right, it either lands 1, 2, 3, 4, 5, 6. How many of those answers are the right answer? 1. Out of how many possibilities? 6. So you have a 1 in 6 chance of rolling the die and having it land on the right answer for that question. So x times p of x means to take the value of getting it right times the probability of getting it right. Sigma means add, which I'm doing right here, the value of getting it wrong. What's that? The value of marking an answer wrong. How much is that worth? It's worth a negative 1/4 point, or 1/4, or 0.25. Okay, that's the value of getting it wrong. What's the probability of getting it wrong? How many of those outcomes out of 6 are wrong answers? 4 of them. Because one of the choices is right. One of the choices is blank. So how many are wrong choices? 4 out of 6. So the value of it times the probability of it, plus the value times the probability, plus what's the value of leaving it blank? 0 times the probability of leaving it blank. There's a 1 in 6 chance you'll roll a 6, which would force you to leave it blank. So this will be the expected value of using this method on one question. So what's your expected point value on that one question by using this method? What's 1 times 1/6? 1/6. Now, we're going to add a negative times a positive, which will really be to subtract. What's 1/4 times 4/6? 1/6. Plus, what's 0 times anything? 0. So what's 1/6 minus 1/6 plus 0? 0. Your expected value of using this method on one question is 0. So great method, but it's really worth nothing. Okay? Now, if you use this method over the course of a 30-question test, which is part B, right? What is the expected value for a 30-question test? You just take the value of one question, which was 0, times 30. 0. If you use this method for this entire test, you can expect to get a 0 on the test. What's the maximum correct score if you get them all right? 30. So if you use this method, the average student would get a 0 out of 30 on the test. No, if you got them all wrong, you would get a negative quarter per. Yeah, what would you get? Negative 0.7, negative 7.5? So this is not the best method. You're probably going to get a 0 on the test. But that's a little bit about expected value. Just keep this formula in mind. You're going to use it on example A and on number 3 on the green worksheet. You take the value times the probability, value times probability, and add them up.